Hello everyone, my name is Daniel Thomas, Product Manager for RFID at SICK. I will talk today about RFID in automotive production. The following presentation was prepared for an event, for a webinar at RFID Journal. Unfortunately, we had a very poor quality during that event, so that's the reason why I will record this presentation again, that you will have it in a better quality now. Let's start with this. So, RFID in automotive production. I want to focus on the following 4 applications: car body identification, RFID-based Kanban system, identification of tires, and automotive part identification. So the first one, car body identification. On this picture we see a typical setup of an RFID identification point in car body identification. Here we see an RFID tag, which is a removable high temperature label attached with a plastic clip inside the wheel case of the car body. This is not the only possibility to how to mount a transponder on a car body. Another possibility could be, for example, a fixed on metal temp tag, which is glued or with adhesive stick directly to the chassis itself. On the other side, there's the RFID reader. Here, an RFID reader with an integrated antenna. The typical read ranges are normally less than 2 meter range. Those RFID readers are typically connected to a PLC environment and communicate via a field bus like Profinet I/O or Ethernet IP. So, but why is RFID UHF such a good idea for car body identification? Let's look on the next slide. So, on these 2 pictures on top, this should display a generic automotive plant with the different production areas. So the car body is traveling from the body shop through paint, through assembly, to finally logistics. On the left side, we have the situation that we are using in every area another identification technology. So we see examples for laser-based barcode systems, camera-based barcode systems, radio-based systems, active, passive, microwave, infrared technologies. A lot of multiple different technologies, how you can identify a car body, and every technology with its unique data carrier. On the right side, we have a setup where we are using just one data carrier in one technology, here UHF RFID, that identifies the car body from the beginning to the end. With this setup, you can reduce costs by using just one tag and reduce complexity by using just one single technology for the whole identification process. Using one technology has also the advantage you get rid of all the conversion points where you had to convert the data from one data carrier to the data carrier with another technology in the next area. So this is a much more streamlined process of identification through car body identification. Okay, let's have a look from a different perspective on this topic. So looking on the requirements for the data carriers, we see in different areas we need shorter ranges, some longer ranges, some with high temperatures, and some areas no line of sight, as in paint shop. The data carrier must be resistant to chemicals. And there's sometimes also a different angle and orientation between the data carrier and the identification sensor. So in this table, laser-based barcode cameras, laser-based barcode scanner, sorry, and camera-based code readers, and HF RFID sensors and UHF RFID sensors are compared with their different requirements in each line, and we see that the UHF technology is competent to provide all these different solutions to these different requirements. In general, I would say the large reading field provides a lot of flexibility for the UHF technology. It is very much forgiving versus tolerances. You don't need to be exactly in a depth of field or not in a certain laser line as in barcode scanners, and you have a quite good flexibility in the huge reading field. So also maintenance free, there's no window that need to be cleaned, and also the data carriers can be rewritten again if additional information needs to be added at different workstations. So these are the main reasons why RFID is so powerful in RFID, in this RFID application for car body identification. Let's have a look at some examples, at some pictures. On the left top side, we have an identification process probably before paint shop somewhere. There we have an RFID reader again on the left side, and this is identifying a small transponder label hanging down from the chassis. On the excuse me, on the center top picture, we have an RFID reader hanging a little bit higher. When I remember correctly, this is identifying the transponder on which is attached to the rear side window of the cars. Then on the right top picture, there's another picture from body shop where the RFID reader identifies an RFID tag attached to the somewhere the part on the bumper of the car. Left lower picture, again, another body shop, RFID device identifying an RFID tag on the chassis next to welding robots. And this is, even in this harsh environment, this identification process is possible. And on the right bottom picture, we are seeing, again, an RFID reader that identifies a fixed on metal RFID tag mounted here on the chassis. And we also see an engineer who is using a tablet to install the right configuration on the RFID reader. This engineer is now using an installation tool that we provide for free with our RFID readers. Here you can see, for example, how much transmit power is necessary to identify this specific transponder on the car body at that position, and how strong the RFID tag is received inside the RFID reader again. So these two parameters are very helpful when you want to create a reading zone, a reading area of not having any issues with overshoots, with cross reads to neighboring applications. So this is a very powerful tool, not only good for car body identification, but also for very many other UHF RFID applications. So next RFID application in automotive production, RFID-based Kanban. So I guess everybody of you is familiar with Kanban processes. Within a Kanban process, this card has a very foundational use and is very important in this in this process. This card, which has the information of the material, the quantity, and the destination for this container, is mainly the tool that organizes the replenishment process. So when a full box is delivered to the production line and the box gets empty, an operator will take this Kanban, this card, and uses this to start the new replenishment process by, for example, posting a new order in the ERP system. So this is a great process, established since decades and proven all over the world. Now sometimes we see some people are using an RFID tag together with this Kanban card. So here in this example, we have a let's say 5-cent paper. No, not even paper. An RFID inlay sticked on this Kanban card, and now what the question? What is the big improvement? What is the advantage now using an RFID based Kanban system? So a paper card with an additional RFID label on it. So let's have a look at some processes shown in those pictures on the lower side of this page. So people say we're using RFID within Kanban systems. They say that you can reduce manual efforts for the operators. For example, a replenishment process should be organized. For example, let's take the left side, by putting an empty container in the top level of this flow rack. So the lower levels are filled with full boxes, and the operators are using this material from the lower levels, and if one container gets empty, the operator will move this empty box to the top layer, and then on the top layer we have RFID antennas that identify this empty box, and those read results from the transponder of the Kanban card will be provided to a higher system that is directly organizing starting a new replenishment process or posting an order in SAP, for example. So. Or on the right side, for example, there's an RFID reader looking downwards, hanging on the ceiling, and is identifying Kanban cards that are stick to the top of those containers. Those containers are stacked on a cart, and those cards are put in those lanes. Some customer call this a supermarket or first in first out lanes, and these RFID readers are also seeing can assign the position of these containers to a specific lane. Not only identifying that there's somewhere an RFID tag, but also tells you, okay, this is inside the second or third lane of this supermarket. On the other side, there's another RFID reader looking downwards to those cards, and here if a card with an RFID tag is leaving this zone, that is also updating this on the left side, this overview of the current stock level inside this supermarket. So the benefits are that you get a real-time information of the physical material flow, and this gives you a transparency, and where you can run reports and document a history about the real material flow. And this is a foundational basic to do continuous improvement, and which also leads to the possibility of reducing your real stock. Because when you know where the assets are, where all the material is in real time, you don't need to waste additional safety stocks in your flow racks, for example. Okay. Let's talk about some challenges within RFID-based Kanban. So one topic we are often facing is we having these containers, typically plastic containers. Plastic is not a problem for RFID, but sometimes these plastic containers have not just pure plastic, but also additional material inside that makes them a little bit electrically conducting. So these electric static discharge containers used for electronic products mainly, they have an impact to the performance of transponders. Due to this, I attached this screenshot from on the right side, the right top picture, of a tool that is measuring the performance of RFID tags, a Voyantic tool, and the eye-opening thing. Sometimes we see here that the same transponder is behaving differently on different background material. So please be aware of using the same tag on different objects can have an impact to the performance, and this needs sometimes a different solution or a little bit more effort. So for example, for ESD containers, I would not recommend generally the same paper labels, for example, you're using for standard plastic boxes, but using maybe a tag that is more suited for this background material, or using spacer would be a good workaround. Overshoots or cross reads to neighboring RFID tags that do not belong maybe to the event where you want to start a new replenishment process. This requires the ability to reduce the size of the reading field to a minimum, for example. And here readers are very good in this situation, where you can reduce, for example, the transmit power down to 4 dBm transmit power. Normally, always the more transmit power you have, the better. Often in some applications, but here it's in some applications exactly the opposite. So the less, the better. A typical network of RFID devices within a Kanban network is often a power over Ethernet network. So that means you have power over Ethernet switches with 32, 64 ports in your production logistics areas where these RFID devices are connected to. It's a minimum effort for cabling. You can use one cable to provide power and Ethernet communication. And you can also provide this power and communication also over a quite huge distance. So typical limits are more than 100 meters for power over Ethernet devices. IT integration. So the RFID sensors within RFID-based Kanban that are identifying RFID tags, and on basis of this, a posting or booking of new material needs to be done in your ERP system. Is normally not organized that the RFID device is directly connected with, for example, the SIP program. There's a layer in between called a middleware often, and here it can be helpful sometimes to use also a middleware agent, also a piece of edgeware, which is running directly on the RFID sensor itself. So if this might be the case within our identification products, we have a, let's call it a layer for more flexibility inside the device. This is called SIG app space. And here programmers can code an individual new software application in addition to the standard functionality on the device. Worldwide use. So here we often these Kanban processes are in huge companies that are not only located in one country. Those Kanban systems are rolled out in multiple countries. So here it is good to have a portfolio which covers more than one country. So within SIG we are providing many radio approvals for countries all over the world. So you can have approvals for devices with approvals for North America, not only US, but Mexico and Canada, South America for Brazil, Chile, South Africa, and so on. Also Asia and Pacific region as well. Good. Next application, RFID in automotive production for identification of tires. So, in a tire plant in general, there are many opportunities for RFID. You can track pallets, racks, trolleys, bobbins, and other assets with an RFID UHF tag. Here I want to focus on the identification of tire itself. Those tasks are mainly at the conveyors shown in the upper part of that picture for the green and the finished tires, and the logistics part maybe on top of the picture. So maybe as a background information, so SIG has a long history in tire identification with optical systems. An example you can see on the picture. You see these 3 cameras organized in a tire lector array, which is identifying in this case probably the bead label here on this tire. Now, when RFID tags are placed or added to tires as well, these these identification stations with optical systems can now be upgraded or replaced with RFID readers. Here we have a little bit different challenges with than with cameras. We have I wrote low performing tags. That's probably not fair for the transponder manufacturers. What I mean behind this is that the tag is in a very challenging environment. So inside a tire we have a lot of different materials. We have a lot of mechanical stress to this RFID tag, and we have metal parts in the vicinity of this RFID tag that is also impacting its performance. So we will. It's not as easy as to read a 4-inch paper label on a cardboard box with an RFID reader than the reading a tire RFID tag inside a tire with an RFID reader. So also where it is difficult, sometimes you don't know if the tag is on the top or on the bottom side of the tire. The orientation of the tire can also have an impact depending where the antenna of the RFID reader is. We can not only read with RFID, but we sometimes also need to write. This takes a bit longer time, and this also in a moving process sometimes leads that we need a quite huge area where we can communicate between the RFID reader and the RFID tag inside the tire, that we have to use bigger antennas, multiple antennas, just to fit this requirements as a good solution. So let's have a look at 3 examples of an RFID identification system for tires on conveyors. So on the left we have a quite simple setup. We have here a single reader with an integrated antenna, powered with 24 volts and communicating maybe with a PLC via Ethernet, Profinet or Ethernet IP. So this is just is possible with one single device. A little bit of framing and that's it. So on the center picture, we have a combination of an optical system with a tire lector array, for example, and then an RFID reading station with multiple external antennas. This might be necessary because the tires are so huge, maybe for truck tires, because the area where the transponder could be is not covered by one single antenna. Or another reason could be that we also want to write data or read multiple memory banks of the RFID tag, not just reading the UII, but also maybe writing user memory and locking the memory banks afterwards, so that we will need the RFID tag more time in this reading area. And when this conveyor is moving with a certain speed, we need to make sure that this is covered also probably with another retry. So, and then there's another a picture included on the left top of the center picture. This reminds me to our tire analytics software. This is a tool to monitor reading stations from a central point. This tire analytics software is a derivative from package and baggage analytics, which are used in the courier express parcel industry and at airports, for example. We have also many reading stations and also want to monitor from a central point the start of your reading points. For what read rate is there? Is this available? Is there a problem or something? This can be organized and monitored with those software tools like tire analytics. So, and on the right side we have a even more complex system. Let's say here we have a tunnel with shielding and absorbing panels. This can be helpful sometimes when you want to reduce cross reads to neighboring conveyors, or also for increasing the assignment with small object gaps of tires. So you see that one reading station could look very different, and the reason for this is the different requirements we have here for the different use cases. So just to mention maybe some dollar numbers here, maybe on the left side we start maybe around $3,000, and on the very right side we are probably that's probably more than the $30,000 that could end up in such a solution. So it's good to know in advance. So what are the real requirements at this individual ID points? So again, in this slide, it is important how fast is the conveyor speed, how wide is the width, where's the tag position, is it on the upper or on the lower side of the tire, how large are the object gaps from one tire to another tire, what actions on the interface needs to be done, is it only a reading or a reading and writing and locking station, so how much time do we need for all this these actions on the interface. And of course all the other infrastructure information is also great to know. What hosting systems, what protocols do you need, do we need analytics, and of course what location are these ID points, in which countries do we need to install them. So again, this slide shows again that our portfolio should have the right should have the right solution for each application. Doesn't matter if it's a simple setup with just with a serial component like just an RFID reader and maybe an additional external antenna, or are we talking about more complex systems with customer project management that needs to be included with additional controllers, combining other technologies and mechanics to this solution, but which is also possible within our portfolio. So, last application for RFID in automotive production for today, automotive part identification. Those applications are along the material flow from suppliers to car manufacturers. For example, on the left side, we find read points at assembly lines where, for example, an electronic module is already equipped with an UHF tag. So not just the workpiece carrier is identified by RFID, but the workpiece itself. So this is, I think, also a trend which we'll see more in future. Having already automotive parts equipped with an RFID tag, and those can be directly identified on an assembly line as well. And then you get rid of the risk that the part itself is maybe exchanged to another carrier, and then you probably lose track of this production history. Other parts, bigger parts like seats or dashboards are also equipped nowadays with RFID tags. And then when all these automotive parts are put together to one vehicle or inside a vehicle, we see at some manufacturers already an RFID gate at the end of final assembly, where this gate is identifying all these often safety relevant parts and using this information to trace which automotive part went into which individual car. So yeah, I think we'll have here a lot of new reading stations in future as well. Again, this slide should show that we have a wide portfolio of RFID readers for short, mid-range, long-range with direction detection or combined into a system like in a tunnel or in a gate, where we can solve many different applications, especially in automotive industry. And we are happy to find more applications with you in future. And normally at this point there was a questions and answer sessions for this webinar. Now I'm standing here alone recording this presentation, and I hope the quality of the audio was today much better. And if you have questions or feedback, please feel free to send us an email to info@sic.com. Thank you very much.